Dear students, in today's lecture, you will know about the vertical structure of the atmosphere. So let's start our real discussion point of today's lecture. We'll discuss about the vertical structure of the atmosphere, also about the critical perspective of the atmosphere or atmospheric layers. What are the critical aspect or beneficial aspect? A point of concern of the atmospheric layers for the today's scientists and also to our dedicated changes toward up research in that field of the climatology and related to the atmospheric layers or vertical structure of the atmosphere. So let's start first about the intro and introduction base of the atmosphere. Vertical structure of the atmosphere means and what's its introduction and background. So if we understand not only chemically, like we know the atmosphere is the combination of the gases, many gases around us. That's if we, because we know the atmosphere is what that's around us, that the combination of gases. But physically and also chemically, the atmosphere is not uniform throughout. Like if you see, the some gases will be remain the same in one place of the atmosphere, but throughout the atmosphere there is no uniformity, there is no such commonness in the physical structure of the atmosphere. Like here we are discussing the vertical structure of the atmosphere. So here if you see, the commonly accepted delineation of the atmosphere into series of layers can be seen, that is based on the temperature. Here I will discuss first in that graphics which I have given. In brief, we can understand array in common array in simple words, that if we mention here the very geosphere or basis of that or what we are laying, and that surrounding us is the atmosphere, and if we go that point towards the sky to the limit of that galaxy system, like we go upward in the vertical form, we will experience not the uniformity in that kind of, like if you go the like the pressure will remain like that, not it's not like that. If you go like that, the base will be like that. No, obviously there will no, there will be difference in temperature as we go towards the altitude, because if we are going up, we are uh, proceeding with that some kind of length, that is in the kilometer. If we take it here as plus 25 Celsius, here in x-axis you can see, if you go toward the minus x-axis, like it's the x-axis is minus x-axis, if you go toward the minus x-axis, the 0 Celsius here is mentioned. But yes, why the plus 25 or plus 20 is mentioned? Because we know that our room temperature remains are mentioned as, are being known as plus 25 or 25 Celsius. So in many places the variations are there, like the tropical areas on earth or the geosphere, some different kind of temperature. In polar areas there will be different kind of temperature. However, the uniformity is not there, because if we see the temperature on that plus 20 Celsius, if we go upward, that in that very layer, that troposphere, it will first decrease, then it will increase, then it will decrease, and again to thermospheric atmosphere it will again increase. Firstly, we have to know about the fourth layer, four layers of that atmospheres, or what are actually vertical structure of that very atmosphere. So first comes the troposphere level. Our troposphere around that is surrounding from the earth's surface up to that tropophase, and that's about 17 to 20 kilometer up from the earth sphere. We will see from the surface of the earth around this level. If we take it as a latitude and we go upward, that is troposphere. What's actually the tropophase? Every after every that layer, which is delineation of the layers of the atmosphere, there will become the past stage, and the past stage is actually for the phase where the temperature will be in the little or about that, in that little kilometer range. it will be in the past stage, or it will be in isothermal stage. The temperature will remain same up till when the next layer or next boundary of delineation of the another layer is being started. So here every layer you will see, like from the troposphere there are the four, basically three are you can say again the four layers, but the basic one are the three, that's the troposphere, stratosphere and mesosphere. The thermosphere, and obviously if you go up even here you can mention about that thermosphere or exosphere, even the ionosphere. But point of concern for climatologists, for many environmentalists, remain the troposphere and stratosphere, because all the phenomena here we will discuss in very detail in the coming next detail of that very layer, that the many phenomena processes occur in that part, and also the surface above that earth. It is a point of concern for us, because all the processes around are in the troposphere up to the stratosphere level. So if we start from the troposphere and that plus 20 or 25 degrees Celsius, first the temperature began to low if we go from that very temperature or basis of the 0 or 1 kilometer. So if we start with the 0 kilometer, if here you can see the points, the troposphere leads toward a 17 to 20 kilometer. After that the stratosphere level is about 40 degrees Celsius till that 60 to 50 kilometers Celsius, kilometer. After that is the mesosphere level, that goes up to the 80 kilometer above that earth surface or geosphere. After that there is no boundary, like no concern boundaries exist, that we also mentioned in the upcoming explanation, up till that exosphere. So firstly if we go from the troposphere level, from that very earth surface, if we go towards the upward is like that, the temperature will fall. Here will fall the temperature, it is mentioned about 5 to 6 degrees Celsius about from 1 kilometer. On every kilometer we move upward, the temperature will fall like that, and it will fall up till we go to that troposphere, tropopause level. It will fall up to your, you can mention like in that phase up to minus 50 degrees Celsius or till even minus 50. So minus 50, after that the thermal phase will come, and again the temperature will straight in that stratopause straightly goes high up till that 0 Celsius or till 0 to 5 Celsius, and the 0 Celsius that will also thermal phase will come in that stratosphere level or the upper layer of that stratosphere. In that stratosphere layer again the temperature will goes towards the less up till even minus 80 degrees Celsius or minus 90 Celsius has been observed or has been speculated. After that there will be also isothermal phase in that phase or pause level, and after that the temperature even goes and so much goes that even if we go for the plus level, the plus even hundreds or thousand, even what can be speculated about that 100 kilometers you can stay about here to increase. That is in ionosphere, exosphere, etc. thermosphere. That's why it is called thermosphere, because it's the very hot layer of the all the spheres of the vertical structure of the atmosphere. So firstly if we start from the troposphere, that's the very important layer, as well as the stratosphere, because in that troposphere upper level in 17 kilometer to up to you could go to the 50 kilometer or 60 then 50 kilometer. So that level is about the ozone, the lower layer of ozone. What it plays actually, it radiates that or insulate that part of the earth sphere, and it is acting like a blanket to insulate that layer of long waves that can go. It can be then it can be some trapped thermal are being again rebounds toward or reflect toward the earth surface to be insulated for the thermal immersion and also for the thermoregulation. But the upper layer, what's actually what I have said, that in the troposphere and stratosphere are the very important part, because this upper part of the zone, it will trap the upcoming ultraviolet radiation that are with the low wavelength but high energy, that is harmful for that we are sphere. If it pass from that, if in other case the ozone layer is depleted, is we see in many kind of climatic chapters or climatology that if it is depleted from any kind of danger other activities, so then it will come, and obviously it can make harmful repercussions or effects on that sphere. But that sphere is the part that stratosphere up to the upper layer of that stratosphere is making that ozone layer and as a blanket again for the reflection of that harmful rays, but the beneficial rays to pass through it. So that's why the troposphere and stratosphere will be concerned as the very critical and very important part of the vertical structure of that atmosphere, and that is one concern of observance and also observed by ozone layer or the troposphere stratosphere observed we been observing or been the point of research concern the climatologists, environmentalists, and many other kind of agencies like that. So let's start about the layers in a little brief introduction or background. What's actually their properties are, what's their physical chemical properties are. The lowest layer, as I have mentioned, no need to go for the graphic level again because you have seen it, observe it in your clean eye. So if you can also again see it and you can reference with it and you can go for other detail. But if you are, I will only give you a point of concern about the basic intro and background and physical properties of that layers of the atmosphere. Firstly, the troposphere. That's obviously the lowest layer. It ranges in thickness, what I mentioned before, it about the 8 km at the poles to the 16 km at the equator. Why it is low in thickness at the poles but more in thickness at the equator? Because in the polar areas we know the high altitude and Arctic and Antarctic circle, because of the high altitudes of that ranges of the snow belt, so that altitude will be a little bit higher and the position of the atmosphere will be a little higher. It will be low for thickness for that layer to occur. But in the equatorial area there will be much area for that from ground level toward that troposphere level. That's why at the equatorial area there will be much area to occur this, to compose the gases and compose that layer. So that's why at the equatorial area there is 16 up to 16 kilometer, and at the polar areas there will be less area to cover or to be composed by those gases or that form of that layer of the atmosphere. So there is also difference in energy, also energy temperature budgets at these two locations, because if we go for the energy budget, the temperature obviously, as we know that decrease altitude at rate of what that I've mentioned about 5 to 6. It's about 6 to 5 or around to 5 to 6 or 5 to 7 you can mention, but it should decrease with every kilometer about 6.5 Celsius per kilometer within time. In this layer, if we go upward in altitude base, the temperature will decrease in every kilometer about 6.5 Celsius per kilometer. So the tropospheric lapse rate, that's the tropospheric lapse rate, because if that temperature is lapse from the its own original form or from one phase to another, then it is called tropospheric lapse rate, because in that temperature change the tropospheric layer is being on the basis, so that's called the tropospheric lapse rate. Temperature at the upper edge of the troposphere average between -50 and -60 Celsius, as I mentioned. But in equatorial areas region, it reaches its greatest altitude, because the altitude areas is much. Values may be as low as -80 as well, because there is also difference in the that thickness. So due to that thickness in the equatorial area this may reach to the -80, but in the polar area it may remain -50 Celsius or 60 Celsius as well. But it's also obvious that there will be also, due to the Arctic circle or due to the frozen area, their temperature will also be high as well. So the tropospheric lapse rate, due to the tropospheric lapse rate, based radiation regularly produce instability in the system, or in that our system, our sphere, our atmospheric layers, and it helps to make the troposphere the most turbulent of the atmosphere. So troposphere is also concerned is the most turbulent, like it's very unstable layer of that atmospheric layers. In that, due to the tropospheric layers rate are much high variations in temperature. The troposphere contains also as much as the many amount of gases, combination of gases towards the troposphere to stratosphere, but mostly at the troposphere level up to 20 or 30 kilometers. About 75% of the gaseous mass of the troposphere. Also, all the water vapors, that is the H2 form, that's vaporized form, and other aerosol as well. So that's kind of the heavy blanket or the surface of the geosphere, surface of the earth. So in that troposphere, stratosphere, both are point of concern, but the troposphere is very dense, and that's because of the 75% of the gaseous molecules. It is also the zone in which most weather systems develop. That's why it is very important, as I have mentioned before, that troposphere along the stratosphere. But troposphere is very important because of the first layer, and it is the point of concern because of the weather system develops here at that about the Earth level, and also it runs their course along the cycle of the season, etc. These factors, however, together with the high level of human intervention in that part of the atmosphere, ensure that many of the global environmental concerns are also even there, including like acid rain, atmospheric turbidity, and global warming, etc., have their own origins, are reached therefore less extent in the troposphere, because the troposphere is a point of concern because of that all phenomenon, and also the beneficial part of the atmospheric level, atmospheric layers. So the troposphere marks the upper limit of the the tropopause that comes up next to the troposphere. As I mentioned, that here the temperature will be again go towards the higher range in the stratosphere. So in that part tropopause, it marks the upper limit of the troposphere. What up next is the stratosphere, the very next important layer of the state of the atmospheric layer. Beyond tropopause, there come the stratosphere, the up next or second layer of the atmospheric vertical structure. Isothermal condition will prevail like that, but temperature remains constant because isothermal condition is there. However, at about the value reached at the tropopause up to an altitude of about 20 kilometers, about that troposphere level, if the tropopause come about up to an altitude of 20 kilometers, the temperature will be that. But about that level, after that the pressure then again will go towards rise, as I have mentioned and have shown you in the graphic, and will go up to the 50 to 55 kilometers above. You will go to surface, the stratopause, the temperature close or even slightly above zeros are common. At that stratopause level or the second layer stratosphere level, the temperature of zeros is common, because this is caused by the presence of ozone, which absorb ultraviolet radiation and thus making 0 Celsius from sun, and warms the middle layer and upper layer of the stratosphere, creating a temperature inversion in that part. The combination of that inversion, what inversion then makes the isothermal layer, that's that part. The isothermal layer in the lower stratosphere creates very stable condition, because if you go for the thermality, and the stratosphere as none of the turbulence related with the troposphere, because of that the turbulence remain only in the stratosphere after the troposphere, sorry, after the troposphere, but not the thermal sphere of the stratosphere. But this is an important implication for environment. Why then the stratosphere is an important implication for environment? Because any foreign material introduced into the stratosphere tends to persist. It tends to persist there much longer than it would if it had remained below the troposphere or tropopause. Sorry. Environmental problems also like ozone depletion and atmospheric turbidity are aggravated by this situation. If the ozone layer become aggravated or become depleted or become degraded in that layer or the upper layer of the ozone which is in the stratosphere. So after that stratosphere, there comes the mesosphere, temperature again decreases, I have shown in the graphic level, with decrease with the height above the stratopath, that's the upper layer of the stratosphere, and then goes toward the mesosphere, and into the mesosphere falling as much as low as minus 100 Celsius at the mesopath. At the mesopath level, there will be again the pause in that scenario, but temperature at that point will become to the minus 100 Celsius. If you go in the graphic you will experience that some 80 kilometer above the surface of the earth. If you see the kilometer range, you go there 80 kilometer above that will be the minus 100 Celsius. But about that, that is last part is the thermosphere. After that, it's also called the ionosphere or exosphere. It stretches above this altitude with no obvious outer limit. Like if you go above the 80 kilometer, there is no obvious limit that can make it concern for you as such in the concern that it is in such accurate for that, but it goes upward, that temperature also goes along. That's what it's called thermosphere, because in this layer the temperature may exceed even above or exceed to 100 degrees Celsius, 1000 Celsius or above that. So that's the thermosphere, and the ions are all in our gases run in ion form, not the atomic form. So that's also the exosphere as well, because it's the exit form of the all atmospheric level, atmospheric layers. So that was about the vertical structure of the atmosphere. What's actually the benefits or electricalness of the atmosphere? What are the critical perspective of the atmosphere, atmospheric layer? What are its benefits, and what's actually its parts on vital, why they are vital? Because we know about nature of the thermosphere and all these spheres. But in thermosphere, if I have lastly mentioned in that next part, previous part of that lecture discussion, it's due to the surface properties and many other kind of activities there, and very high temperature, very high temperature is far from complete. About that, speculations are there. How the link between the upper and lower layers of the atmosphere remains speculative. Like about the mesosphere and the thermosphere, there will be speculation or studies are there. But for the climatologists and environmentalists, as I have mentioned, I will again here discuss, and I will again mention again that most important structural layer are obviously the very start layers of the atmosphere, that is troposphere and stratosphere. That is the troposphere and stratosphere, because the structural element, and these are the structural and functional element of the very Earth surface or geosphere and biosphere are so concerned on that two spheres. The main concern, because the main conversion of the transfer energy in the Earth atmosphere system takes place within these two layers of the lower atmosphere, as well as the interference with these mechanisms has contributed to the creation and intensification, like a high to become the extreme of the current problems in the atmospheric environment. Like if we go from the troposphere in the stratosphere, the point of concern remains the ozone depletion or the climatic change that comes in that energy budget base inversion or variations in that troposphere layer or stratosphere, because we know that in the troposphere level, if the ozone layer is started from the about 17 kilometer up to the stratosphere in that 40 or to 50 kilometer level, upper level of the stratophase. So in that layer, the ozone depletion can cause the point of concern for the climatologists and every kind of point of concern for the many other observational scientists and other agencies are national international phenomena processes that happen due to the processing that two levels. So that point of concern is very beneficial layers. So that's why they call structural layers for the environment and climatology perspective. So that was about the vertical structure of the atmosphere. Its four basic layers are the two basic layers, and the two other one as a speculative base. Their retail and structure, or their physical-chemical properties, are their beneficence, especially troposphere and stratosphere, and the critical perspective are beneficence of the atmospheric level as a whole in that lecture.